Alright, so day 8, I think. Mary Martin picks candy out of the bag, returns the color, records the color, returns it to the bag. So it's with replacement. He does this 20 times. How many times should Martin expect to pick an orange candy? Well, orange is 10. There's 10 out of, let's add this up, 15, 25, 25, that's 50. So there's 10 oranges out of 50, and you're going to repeat the process, right? The trials 20 times. So out of 20 times, how many times can you expect to get an orange? So imagine all of these are in the bag, and you take one, look at it, put it back, take another one, look at it, put it back, and you repeat the process 20 times. So out of the 20 times, you expect to get an orange, a total of 4 times. So this question says, and now I gotta go up here. This question says, if the wheel stops on yellow, green, or blue, you get a price. So every time the yellow spins it, you get 80 cents. If it lands on green, you get $1.30, and if you get blue, you get $2. So they're gonna repeat this 500 times. So if out of 500 times this wheel is spun, what do you think the total amount of prices will be given, right? How much money would the owner of this wheel have to fork out? Well, yellow, so let's look at yellow. There's yellow, there's green, you get paid, and blue, you get paid. So we gotta do 3. So there's 1, 2, 3 yellow. So 3 out of 12 is yellow. So you have a 3 out of 12 chance. You multiply that by 500, right? So if you get 3 12s out of 500, you're going to spin that out of the 500 times that you spin. It should supposedly, theoretically, you're going to land on yellow 125 times. So let me take this guy out, right? It will land in yellow 125 times, and then every time that it lands in yellow, you pay the winner 80 cents. So let's multiply that by 80. So with the yellow, you're expected to pay 100 bucks out of 500 spins. Repeat the process with green. Green, there is 2 greens. So 2 out of 12. 2 out of every 12 times you expect to land on green. Let's repeat this. Let's multiply that by 500. So if you spun that wheel 500 times, you expect it to land on green 83 and 1/3 of the time. Now you can't have 83 and 1/3 of the time, so let's just call it 84. So 84 times out of 500, it lands on green. And then if it lands on green, you pay $1.30 each time. So let's multiply that by $1.30, and you get that you're going to end up paying $108.33 rounded. All right, so that's how much money you expect to pay out of 500 spins. And then we have blue. Blue is 1 out of 12. So 1 out of 12 chance of landing in blue. Let's multiply that by 500. Right, so if you spun this 500 times, you expect to land in blue about, well, it says 41 and 3/4, right? So we're not can't have 41 3/4 of a spin, so let's call it 42 spins. So 42 spins out of 500 will land in blue. And if you multiply that by 2, right, because every time you land on blue, you get $2. You expect to pay $84. So they're asking us, how much would you expect to pay? Well, it would be 100 plus 108.33 plus 84. So 108.33 plus 84 plus 100. It's about, I don't know, give or take, $292.33, if my math is correct. All right, it's a little bit of work on that one. 3, she spun this 50 times, recorded the results. Here are the results. Based on the results, this is experimental probability. How many times should Karen expect a spin to land on 3 or 4 if she spins the spinners 300 times. So how many times? So P of 3 or 4. So if he lands her 3 or 4, you win. Probability of landing a 3 is 10, and probability of landing 12 and 4 was 12. So 22 out of 50 chance of this happening. Well, if you multiply that by 300, right, we're going to get 132 times. So probability of that happening out of the next 300 times is 132 times. For the arrow on the spinner shows, on the spinner below shows, the arrow on the spinner shows below, the arrow on the spinner shown below will be spun 400 times. They're going to take this and spin it 400 times. Based on the theoretical probability, which graph best represents the number of spins in 400 that the arrow will stop in each section. So, theoretically, what would you expect this to happen? So, if you think about it, now, red is 1/4 of the time, right? Actually, sorry, I take that back. I didn't see this one. So, red is... How do I do this easy? So the best way to do it is because it's already to make it easier. Yes, I'm still coughing. I would cut everything in 8s just to make it easier, right? Because you have this cut into 4ths and this cut into 8. So just might as well cut everything to 8s. So let's see. Red. Probability of landing on red would be 1, 2, 3, 4. 4 out of 8, or a half. Probability of landing in blue would be 1, 2, 3 out of 8, or half. Right, half plus 1/4, or 1/8, 3 out of 8. And the probability of landing on white is 1 out of 8. So if you spin this 400 times, so let's obviously use the simplified version here. Half times 400. Theoretically, you expect that to land on red 200 times. Blue, 3/8 times 200. Alright, so let's multiply 3/8. 75 times, theoretically. And then 1/8, the white, times 200. And we get 25 times. All right, so let's try to memorize that. Red 200, blue 75, and white 25. So, because I'm going to have to move this down a little bit. All right. I'll erase this. Is there anyone that shows that red's going to come out about 200 times? Not this one. Red. This says that red's going to show up 50 times, so that's gone. Oh, there we have. Red 200 times. Check. White 25 times. And blue 150 times. No. Sorry. Let me look at the. Hang on a second, guys. We spent 400 times. So red should be 200 times. Well, it says which graph best represents. Well, red 200 times, that matches. White, blue was 75 times, and this one has 150 times. Really? And then they have white as 50 times. Well, I guess this would be the best one, right? D. Unless I multiplied this incorrectly. Let me just go back up. Blue would be... No, it's correct. I just don't know why their numbers are so off like that. 3/8 times, unless I'm off. 3/8 times 400, 150 times. No, I did it wrong. Sorry. I did it wrong. I don't know what I multiplied that. Oh, I multiplied by 200. I should have multiplied by 400. Sorry. So this 3 as a football is indeed 150. And again, here's my mistake. Instead of multiplying 400, I multiplied by 200. So this is indeed 50. Sorry. Okay, so D is the correct answer. Why multiply by 200? 5. Table below shows the results of a survey. 200 people attending a hockey game. It's about 25,000 visitors. Based on the table, how many people out of 25,000 could be expected to buy a pennant? All right, so 200 people. The people out of 200 people who bought a pennant, which is one of those flags that look like this. I think 22 out of 200 people buy a pennant of the right, and then if you're gonna estimate out of the 25,000 visitors that showed up that day, how many of those would buy a pennant? Well, multiply 22 over 200 times 25,000. You get 2,750. So out of 25,000 visitors, we expect to sell about this many pennants. 6. Raphael performed an experiment. Again, here are the results. He will spin the arrow 20 more times based on the results of the table. So experimental probability, which is the closest number of times you expect the arrow to land on the red section. So according to the experiment, 105, so P of red, experimental, was 105 over 200. 105 times out of 200 came out red. So if I'm going to spin this 20 more times, how many? Well, you should expect about half, right? So 105, and again, 105 over 200 is about half, times 20. The calculator says 10 and a half. Right, what's the calculator? All right, so what is the closest one? This one. All right, actually, we didn't even have to use a calculator for this one. All right. 7. Ice Cream Shop conducted a survey. Here are your survey results. The Ice Cream Shop is giving away 240 milkshakes at an upcoming game. How many banana ice cream shakes will they have to make if, based on this survey? All right, so we have how many people? 17. The survey was 17 plus 25 plus 11 plus 18. So a total of 71 people were asked. And banana was 17. So 17 out of 71 people in the survey chose banana flavored milkshake. So on the football game, when 240 people show up, how many should they expect to choose banana milkshake? Well, again, 17 out of 71 times 240, and we get times 240, we get about 57 and change people. 57, 33 over 71. We can't have that in terms of people, so we're going to change that to 50. So about 58 people in the football game will probably ask for banana milkshake. Good flavor. 8. Same type of question. Okay. There was a survey. The preference: own lunch, salad bar, traditional. If there's 1,200 students, how many students are expected to prefer the traditional lunch line? All right. So we don't want to ask 1,200 people. That's why we did a survey. The survey was conducted amongst 56 plus 73 plus 22. So 151 people were asked. Right, and out of those, 56 out of 151 people said, I prefer the traditional lunch. It's about a third, right? So times 1200, we should expect about a third of those, so about 400 people. But what's the actual answer? 56 over 151 times 1200, we get about 445. 5 over 151, which we're going to round to 446. So about 446 out of the 1200 kids should say, I prefer the traditional lunch line. 9, quality control light bulb conducted a random sampling of the light bulbs. So 4 defective bulbs, 96 were good. So out of 100, 4 were defective, 96 were good. The light bulb company makes 6,000 light bulbs in a day. Based on this sample, how many defective light bulbs can the company expect to make in a day? So they what do you call? They checked 100 bulbs. So 4 out of the 100 were defective. So if you want to predict how many out of 6,000 are going to be defective, well, just multiply that by 6,000. Simplify. And 4 times 60 is 240. 10. Oh, I need a bigger version of 10 because we can't see. Joe spun a spinner 50 times. The spinner landed on red 27 times. So let me see. 27 times. Red was 27 out of 50. Blue was 9 out of 50. Green was 7 out of 50. And yellow was 7 out of 50. So we're looking for one of the spinner that represents that type of result. Well, we want a spinner that has green and yellow, the same size. Well, let's see. A sort of works. B doesn't work, so B is garbage. C doesn't work because green and yellow are not the same. And it's either D, green and yellow, or A. So what else do we know? And red was the biggest. Red was about half, so we want red to be the biggest. Look at this one. Look at A. Yellow, green, and blue are about the same size. Well, it's 9 out of 50, 750, 750, and red occupies the rest, right? So 3 sections are about the same, and red being the biggest one. So A is definitely a candidate. Let's look at D. Well, red came out 27 out of 50, which is a little bit more than half. That matches. And blue, green, and yellow are, about the same size. So it's actually D because, look, it's 27 out of 50. I forgot that. It's a little bit more than half, and that letter D has red as a little bit more than half. Let me check A again. And A does not have red as being more than half, right? It has less than half. So actually, it is letter D. Okay. All right. 11. How am I supposed to do these if I can't see? The bar graph below shows the result spinning the spinner 600 times. The spinner has 5 color sections. Which of the spinners most likely produced a bar graph? Okay. I have to see it. So 11. So we want something where yellow. Okay, so not yellow has the biggest chunk. Not half, right? Because if you think about it, it's 0.375, which is, not half. So definitely not, but the biggest. So definitely not A, definitely not B. There it is, right? Yellow has the biggest chunk. Blue comes second, and everything else is the same. Well, blue comes second, and everything else is the same. That makes sense. D doesn't make sense because they're all about the same. B doesn't make sense because yellow is too big, and A doesn't make sense because yellow is too small. And C is the only one that represents the bar graph correctly, where B is the biggest, but not, about 37%. where blue is about 25% and the rest are all equally the same size. So that makes sense right here. C. 12. 25 colored beads. There are 5 different colors and 5 beads of each color. Okay. Mary drew a bead from each side of the bag and replaced it 30 times and recorded as well. So she takes one, looks at it, puts it back. So this is with replacement. Okay. What are the experimental theoretical probabilities that Mary Beth will draw a blue bead when she tries again? All right. Just make it a little bit. So there's 5. Remember, each color has 5, so there's 5 blue, 5 red, 5 yellow, 5 green, 5 purple. This is the result of her experiment. Theoretically, right? Let me write theoretically. Theoretical. Well, there's 1, 2, 3, 4, 5, 6. There's 6 colors times 5, so there's 30. Right? And the probability of getting a blue is 5 out of 30, or 1/6. Alright, so the theoretical probability is 1/6. Now, what is the experimental probability? Well, the experimental probability, well, in the experiment, she did this 30 times, and how many times came out of blue? 5 out of 30. 5 out of 30 is about 1/6. Alright, so do we have anything that has that? Theoretical probability is 1 experimental is 1/6. Why is it 1/5? 1, 2, 3, 4. 1, 2, 3, 4. Sorry, there's 5 colors, 5 each, so this should have been a 5 out of 25 for the theoretical. Apologies. Right, so the theoretical, the probability of she getting a blue was 1 out of 5. Right, sorry, so 5 red, 5 blue, 5 yellow, 5 green, 5 purple. So there's 5 of each color, so 5 times 5, so there's a total of 25. So what's the probability of you getting a blue? Theoretically, 5 out of 25, or 1/5. In the experiment, all right, she took one, put it back, took one, put it back. She repeated this 30 times, which is this number over here. How many times did a blue come out? This number over here, 5 out of 30. So in her experiment, the probability of getting a blue was 1/6. So these are the two numbers we're looking for. Theoretical, 1/5. Experimental, 1/6. And there you go. 13. There's a spinner. Let me just bring this down. Okay, there's a spinner. Esther spins the spinner 8 times and get an even number 5 times, which statement correctly compares the experimental theoretical probability. All right, so the experimental, let's write experimental here. It says that an even number, the probability of an even number in her experiment was 5 out of 8. Okay, 5 out of 8 times she got a even number. Theoretically, so before you actually do the experiment, let's say I asked you to look at the spinner. I said, what's the probability of getting an even number? Well, you would look at it and say, well, it's broken up into 8 parts. And there's how many even numbers? 1, 2, 3, 4. 4/8. The probability of getting an even number is 1/2. So now let's compare the theoretical and experimental. Let's read the sentence. The experimental probability is the same as the theoretical probability. Close. The experimental probability is greater than the theoretical probability by 1/8. Yes. The experimental probability is less than the theoretical probability by 1/8. No. The experimental probability was actually greater. Okay, so actually, this is 1/8. So if you want to make it easier and put it into terms of eighth, you can write 4/8. Right, so now it's easier to compare. So, the experimental probability is greater than the theoretical probability is by 1/2. That's not true. It's greater by 1/8 because that's 5/8 and this is 4/8. The experimental probability is less than theoretical probability. Not true. The experimental probability, as you can tell, is 5/8, which is greater. And the experimental probability is greater than the theoretical probability by 1/8. This one is the one that is correct. All right. 14. Quan spins the arrow on the spinner shown and records the results. So here are the results. What's the difference between the experimental and theoretical probabilities on landing on red? So P of red. So if you were to take a look at the spinner, and I asked you what's the probability of landing on red, you would say, well, it's 1/4. And that's your theoretical. Okay, that's the experimental. The experimental probability. Based on the experiment, what's the probability on landing on red? Well, based on the experiment, how many times? First, we got to add up the total. So we got 21 plus 26 plus 24 plus 29, 100 times. And the experiment, the probability of landing on red was 21 out of 100. Okay. What's the difference between the experimental and theoretical probabilities on landing on red? So what was the difference? Well, notice that this is 1/4 and this is 21 over 100. So let me change the 1/4 into an equivalent fraction out of 100. Times 25 and then times 25. So 25 out of 100 is your theoretical. That's another way of saying 1/4. Now it's a little bit easier to compare, right? So what's the difference? 1 over 25, 5 out of 25, 17 out of 84. What the heck? What's the difference between the theoretical and the experimental? 1 over 25. Well, I'd say 4 out of 100 difference, right? What's the difference between the experimental and the theoretical probabilities? I think that's the probability of red, 1/4 times 25, 100 times 25, okay. Landing on red was 21 out of 100. Let me just add that up again. It is 100. So probability, the difference was 25 over 100 minus 21 over 100. And I get 4 over 100. Oh, I see. And then I can simplify that, divide by 4, 1 over 25. And that's my answer. 15. Rachel flipped a coin 50 times and recorded the number of times it landed on tails. She recorded tails 20 times. So in her experiment, P of tails was 28 out of 50. Which statement describes the reasonableness of this result? Well, theoretically, right, if I asked you what's the probability of getting a tail, it's a half, and if you were to do that 50 times, we would expect it to land on tails 25 times. Did it land on 25 times? No, it landed 28. It's not that bad. It's reasonable because 28 is close to half of 50. Yeah, I'd say that's okay. It's reasonable because there will be more tails than heads. No idea what that means. That's not true. It is not reasonable because she will get 25 tails. Well, she theoretically should get 25 tails. That means that she's going to get 25 tails? No. And it says it's not reasonable. No, it is reasonable. Okay. It is not reasonable because she flipped a coin too many times. Okay, seriously? Not the answer. So the only one is A. The only one that makes sense is A. So, day 8.